Hello everyone, my name is Karthik and today I'm going to give you the project report of Amazon Prime EDA, and this is an EDA type project, an individual project. The project summary is to perform a comprehensive EDA on Amazon Prime dataset. Here we have two datasets to perform EDA analysis, which is uh, the titles.csv and credit.csv. They they include the columns such as person ID, name, character, role, title, type, description, release year, age certification, runtime, genre, production countries, seasons, IMDb ID, IMDb score, IMDb votes, TMDb popularity, and TMDb scores. Now, I have merged these two datasets based on the common ID, and I have performed few analysis and also handled missing values, parse nest fields, which means I have few data in terms of lists. I have separated them into different individual strings. At first, the analysis first starts begin with the basic content type, which is movie versus show, whether the show is a series or a movie, and the frequency of genre, most common age certifications, whether it is TV 13 or PG type, and also runtime distributions. I also used visualizations like bar charts, pie charts, histograms, and I also used word cloud to show which one is mostly viewed in the genre. And while performing these analysis, I found out that drama, comedy, thriller are the most watched in genre, and the most common age certification is TV 13 and PG. And the line chart shows the volume of the content released over the time in the recent years. Box plot compares IMDb scores across genres, and scatter plot shows the clusters of IMDb ratings. And it is observed that the IMDb ratings are graded to the movies compared to the shows, and most runtime of the show is around 50 to 150 minutes, and most longer durations are obviously assigned to the higher rating IMDb's. And there is a heat map that is created, and also correlation map and pair plots. This is my GitHub link that I have uploaded the project, and the project statement that we are going to see today is uncovering the key trends of that influence the subscription of Amazon platform using the Amazon Prime dataset. Our business objective is to perform data analysis on Amazon Prime dataset and finding out which interesting facts about shows and movies and the content diversity and the trend over time and the ratings and rankings. These are the libraries that I have used: Pandas, NumPy, Matplotlib to draw the plots, and Seaborn to show interesting plots. And AST is to abstract trees, word cloud to show the word cloud. This is the two datasets that I have loaded uh, into the credits.csv and the title.csv, and we are merging with the ID as a common column. This is the dataset with ID as a common column. Here we can see that there are total 1,24,347 rows and 19 columns. This is the information about the dataset. Here we have all all the dataset columns and their values as well. Here we can see that there are duplicate values of in the dataset. There are 168 duplicate columns. These are all the duplicate columns that are there. Everything is similar. I have dropped the duplicate values because they give inefficient accuracy to the data. These are the missing values in the dataset. This is the total number of null values in the dataset. In the whole dataset, with the whole 19 columns and 1 lakh rows, we have these many null values. Here we are visualizing how what are if there is any null value to show. Almost every column has, as we can see, almost every column and every row has null values. See, as we can see here, null values are here. Here we are having seasonal values. Here null values in TV, TMDB score. Like that we have all null values. What did I know after the loading dataset? After I have loading the dataset, what I've told you is that I found that there are 1 lakh rows in the dataset, and I found out that the count of all the dataset are not same because there are null values as I've shown. So yeah, what else can we expect from a real-time dataset? There will be null values in some or the other row. There are duplicate values as well, which are referring to the ID and score. Okay, and now we are seeing what are all the columns present in the dataset. The person ID, name, character, role, title, type, description, etc. are the values of the columns. We are describing the dataset, the standard mean, standard deviation, minimum value, maximum value, and the quartile values as well for every row, every column. As we can see that each row is identified by ID, obviously, and it has variables like character, the title of the show, IMDb scale of from 1 to 10, age restriction values from if it is TV PG or PG or R rated, etc. If we are seeing if there are any unique values in the data set. Obviously there are unique columns in the data set. I am describing all the unique values in the data set of all the columns, each by the column. You can see that for the person ID, obviously every person has his own individual ID. For the ID for the show as well, obviously it is individual and unique column for the unique value for the name. Even if the person is repeated, if he has his own name as a unique item, the character that has played, it has the role, whether he is a director or an actor, the title, the movie title, unless until it is the part 2 or part 3, every title is unique as well. The movie type is a show or a movie. The description, every description is unique, and the release year from 1934 to 2021. The age certification types, runtimes, different runtimes. Mostly we can see that there are 100s, more than 100s. The genres, as you can see, the genre, the production countries as well. There are so many mixed production countries. The number of seasons, NAN seasons. Okay, 26 seasons, 6 seasons, 2 seasons, 1 season. Unique value for IMDb ID. IMDb ID is unique for each IMDb customer. The IMDb score, IMDb votes, number of votes given for the movie, IMDb popularity, and the unique TTMDB score. every column has its own unique values, as we observed. Now we are performing data wrangling. Data wrangling is nothing but performing the data cleaning and data uh, da- that basically it's data cleaning. We don't need the description column in the visualizations, because most of the description is only how the movie is and what the movie is. We cannot find any insights from that description column, so I have dropped the description column. IMDb ID is also we don't need IMDb ID, because we don't need from who we have received all these IMDb IDs and ratings. I have deleted also the character column, because we cannot find any insights from the character name from the movie. And I have filled all the seasons which has null values with, I have replaced them with 0, and all the other remaining NaN values with 0 in the all the columns. And in age certification, I have merged age certification with the TVPG, and converted that. If there are any values greater than 21, uh, I have put them to TVPG. And in the past countries, as I have shown you, there are multiple countries for each single movie. I have I have extracted each country from the list, and I have put it as a single string for each one, and I have given it into the top countries. I have also used this in the chart. I will show you in the upcoming charts. As I have shown you, uh, I have I have dealt with the null values in the whole dataset. Everything is similar. Everything is having 1,24,179 entries for all the columns. And as I have removed 3 columns, we can see that there are 16 columns now. That's what I have mentioned here. And I have noticed that there is no language for the show. The language of the show is missing. It would have been better if we have found, they have given the language of the movie. We would have found many more insights on which language movies or shows the people are watching more, and we can perform analysis on that as well. And now coming to the data visualization, the first chart is a pie chart based on whether it is a movie or a show. As you can see, that movie has completely dominated the chart. And coming to the second chart, I wanted to find out for what genres people are watching more. As we can see that drama drama is mostly viewed, around 70,000 from the dataset are only coming from drama, and the top 3 are drama, comedy and thriller, as I have showed and told you earlier. The chart 3, I wanted to find out the trend between the release, how many releases are there per year. As we can see that from 1922 to 2000, we have only a significant chart, and from 2010 to 2020 there is a significant increase in the release of shows or movies from the around the world. And this is the word cloud. This is a word cloud that I have generated based on what genre people are preferring to watch. As we can see that drama, thriller, comedy, drama, romance are the mostly watched among the data set. And there are few others that are you can see that action, western, European drama, crime. As you can see, there are a few other noticeable genres that people prefer other than drama, comedy, and thriller. And next, which actors are mostly the top 10 actors that are mostly acted in the movies or shows. As you can see, George Gabby Hayes, Roy Rogers, Best Flowers. these are the top three actors which are acted almost more than 40 films each. And this is the chart that I wanted to show, which whether the person who in the dataset is an actor or director. As we can see, actor has completely outmatched the director with more than 1 lakh, almost around 1 lakh 20,000 entries. And chart 7, I wanted to show histogram between two different plots together between two score IMDb scores and TMDb scores, though uh, they almost look similar when we look them side by side. Most of the values are almost same. As we can see that there are around 7,500 IMDb scores with 0 and 10,000 scores with TMDb scores as 0. And we can see that the chart is increasing as increasing value and increasing and decreasing. Most of the values in the TMDb score and IMDb score are 6 as well. And as you can see, the most value is 6 and the most value is 6 for both the scores. As I have told you, most at around 6.5 in both IMDb and TMDb values. And I wanted to split the content type that is being produced in the recent times. So I have showed a line chart from the for the movies and series, where movies started from before 1910 and to the 2020, where series started from 1930ish to 2020ish and going on. And we can see that we have already seen that there is a significant change in the release of movies and in the past decade. And the next visualization chart is a bar chart which shows the top 10 producing countries. As we can see, US has outlasted all the other countries. As we know that Hollywood is a very big industry, and US production systems and US production is very different compared to all the other countries. So that's why we can see that US has lasted more. And the next visualization chart is the number of seasons for each for the different types of shows. As we can see, I wanted to concise the chart for only 3 seasons, because most of the shows will not have any seasons more than 3. If there are any more than 3 as well, they would be in negligible compared to the number of seasons for 0, because we have around 110,000 seasons with 0, which includes movie as well. So I wanted to concise to 3 seasons, so we can see that there is very less in the third season as well. And this is a box chart. This is the box chart between IMDb scores for the top genres. As we can see, most of the genres for scores for the movies is around 6 and 6, and for the show it is around 7. And there are some outliers as well. Obviously, we don't expect all the data to be matched with 0 to be perfect. So there will definitely be outliers to be shown. So the top five are the comedy, action, drama, genre, and thriller. And the next chart is the bar chart. I wanted to show the bar chart that is beside each other. So I set the palette to set 2 to show beside each other for each genre. As we can see that the average IMDb scores for action movies is around 5.5, and the animation movies is 5.5, and so on. So as we can see that in most of the genres, show for compared to movie, for the TV shows have more IMDb ratings compared to the movies. this is the scatter plot between the duration of time and IMDb score, and we can see that most of the plot is most of the scattering is there between uh, 50 to 150, and from 4 IMDb score to 7 IMDb score. This is where most of the data lies, and most of the data is for the movie, and we can see the IMDb score for the show is very less compare and no sorry IMDb score is more, and the runtime is less, because most of the shows end between 25 minutes, 30 minutes, or longer shows tend to be between 1 hour. So we can see that the most of the shows end between 50 to 1 hour, and the runtime of the movies is typically for two and a half hour to 3 hours, and some exceptions as well. This is the correlation map to show between uh, all the data types, all the numerical values, data types that include integer and float data types. As we can see that there is a positive correlation and negative correlation between all the numerical types. As we can see 0 0.1, 0 0.2, 1, 0.22. There are negative correlation between each to each. As you can see, most of it are negative, moderately correlated to each other. And the final plot that I have visualized is a pair plot, which shows the pair bit the correlation between each data types. As we can see, TMDB score and person ID. If the person ID is from 1 to 2, we can see all the TMDB scores, and the same person ID and TMDB popularity, TMDB votes, score, seasons, runtime, release year, and person ID. As we can see, we can see all the scatter plots. So what is the solution for the business objective? What can we suggest? We can suggest that if we want to increase the subscriptions for the movie, we can produce this my this EDA analysis will suggest that content for content like genre which has drama, comedy, thriller, or consistently viewed more, and also the runtime is between 50 to 150, and also IMDb rating for the movies. These as I've told, the audience rating for the IMDb ratings, these can be taken into consideration, and also taken into consideration for analysis which can boost the engagement. So to conclude, this EDA project is not only to uh, not only uncovers pattern for the viewer engagement, but also demonstrate the story of power of storytelling. By storytelling, I mean showing all these plots and explaining them clearly, that what happens when we show visually to the team to increase the engagement of the content with the charts. And these charts can be used for both technical and non-technical companies. Thank you.